Let's study about image formation by concave mirrors. Ray diagrams provide position, size, and nature of images produced by concave mirror, based on the position of the object placed in front of it. Concave mirrors can produce both virtual and real images. The table on your screen describes images formed by concave mirrors for different positions of object. Let's elaborate each case by drawing ray diagrams for every case. When the object is placed at infinity. When the object is at a considerable distance, we can say that the object is at infinity. In the figure, the object AB is placed at the infinite distance from the concave mirror M. Now ray of light, which is parallel to the principal axis, hits the mirror surface at point D and gets reflected. The reflected ray DF passes through the focus of the mirror. Similarly, another or second ray of light, which is also parallel to the principal axis, meets the mirror surface at the point E and gets reflected. The reflected ray EF passes through the focus F of the mirror. So both reflected rays DF and EF are meeting at the focus point F on the principal axis. Thus the image is formed at the focus F. Here we can see that image formed is not visible, means the image size is highly diminished, and image is formed at focus F. So, when the object is placed at infinity, the image is formed at the focal point or principal focus F. The image formed is highly diminished, real and inverted. When the object is placed beyond center of curvature C. In the figure on your screen, the object AB is placed beyond the center of curvature C of the concave mirror. A ray of light AD, which is parallel to the principal axis, passes through the principal focus F after reflection. A second ray of light AE, passing through the center of curvature C, falls normally on the mirror surface at point E, and returns along the same path. The two reflected rays meet at the point A inverse on the principal axis. Thus A inverse is the real image of the point A of the object AB. Here we can see that the image is formed between center of curvature C and principal focus F, and also the image size is smaller than the object size. So, when the object is placed beyond center of curvature C, the image is formed between center of curvature C and principal focus F. The image formed is diminished, real and inverted. When the object is placed at C. In the figure on your screen, the object AB is placed at the center of curvature C of the concave mirror. A ray of light AD is parallel to the principal axis, passes through the principal focus F after reflection. Now the second ray of light AE strikes the mirror at point E and gets reflected in the direction A inverse parallel to the principal axis. The reflected rays DA inverse and DA inverse meet at the point A inverse. So A inverse is the real image of point A of the object. Thus A inverse B inverse is the complete image of the object AB. Here we can see that the image is formed at the center of curvature C, and also the image size is same as the object size. So, when the object is placed at center of curvature C, the image is also formed at center of curvature C. The image formed is in same size of the object, real and inverted. When the object is placed between center of curvature C and focus F. In the figure on your screen, the object AB is placed between the focus F and center of curvature C of the concave mirror. Now ray parallel to the principal axis gets reflected at point E, and then passes through the focus F. A second ray of light AD passing through the focus F, and falls on the mirror surface at point. The reflected ray becomes parallel to the principal axis of the mirror. Thus the two reflected rays EH and EJ is converging in the downward direction, and they are actually intersected at the point A inverse. Thus A inverse B inverse is the real image formed of the object AB. We can see that image formed beyond the center of curvature C, and larger than object size. So, when the object is placed between center of curvature C and principal focus F, The image is formed beyond center of curvature C. The image formed is enlarged in size, real and inverted. When the object is placed at focus F. In the object AB has been placed at the focus F of the concave mirror. Now the parallel ray of light AD, which is coming from the top of the object, gets reflected at point D, and passes through the focus F, giving the reflected ray dx. A second ray of light AE passing through the center of curvature C, is reflected back along the same path, giving us another reflected ray Y. We find that reflected rays dx and dy are parallel to each other. These parallel rays will meet at a far distance to form an image at infinity, and that's why we cannot see the image in the figure. So when the object is placed at principal focus F, the image is formed at infinity. The image formed is highly enlarged in size, real and inverted. When the object is placed between pole P and focus F. In the figure on your screen, we have an object AB placed between the pole P and principal focus F of the concave mirror, that is, object is within the focus of the concave mirror. The incident ray AD starting from A gets reflected at D, and then passes through the focus F. A second ray of light AD passing through the center of curvature C, strikes the mirror normally, or perpendicularly, at point T, and gets reflected back along the same path. Now the reflected rays DF and DC are diverging rays, and therefore do not intersect each other on the left side. The reflected rays DF and DC are produced backwards, as shown by dotted lines. On producing backwards, they appear to intersect at point A inverse. Thus A inverse B inverse is the image formed by the concave mirror. We can see that image formed is behind the mirror, and larger in size. So, when the object is placed between pole P and principal focus F, the image is formed behind the mirror. The image formed is enlarged in size, virtual and direct.